Okay, so we're going to look at choosing a value for k. So this is the k nearest neighbor. Okay. Last time we read the data, then got rid of these two columns that are not predictors. We split the data using create data partition into train and valid, and then we ran the KNN procedure with k equal to 3 nearest neighbor. Okay? That is just to get started. But when you're using KNN method, remember we have to normalize the data. Otherwise, the columns that have values that are really large will overshadow other columns that have relatively smaller values. So it is very important for KNN methodology, okay, that we normalize the columns, which is what we did last time. Okay, and okay, so we set up. What we're going to do now is we're going to run the KNN model for a range of k values, k equal to 1, 2, 3, and so on. Okay? And then we're going to look at the accuracy measures for all of those different k's in order to look for the best accuracy, the k that gives you the maximum accuracy. So that's how we can, that's one way of choosing a value for k. K being how many neighbors we want to look at, okay, and then determine a class for each record. Okay. So we set up a data frame with k, a column named k with values 1 through 20. Okay. And then we set up a column for accuracy and we populated that column with just zeros for now. So we're going to build that column in a little bit. Okay. And then we did normalize. Okay, so here there are, early on in the semester, we used scale function to do the normalization. Okay. But this method called preprocess, which is part of Caret library, really very useful because it gives you an opportunity to do lots of transformations, lots of different transformations. So you really should use the preprocess method when you want to do transformations, and normalization being one of the methods available in preprocess. So we set up the preprocess, okay, and we save it in bh.normalize. So here we are not including column 12 because column 12 is our target. That's your that's what cat med v. So we need to normalize only the predictor columns, predictor variables. So we don't include column 12, and the method we want to use is center and scale. Okay, that would do a z-score standardization. Z-score standardization is you take each value and subtract mean from it. So that part is centering. Okay, and then you divide by standard deviation that you're scaling. So x minus x bar divided by the standard deviation. So that will give you z-scores. So this sets up the necessary information for each column. You need the x bar and the standard deviation. So that is calculated and saved here, and then you use the predict method to transform this data into the normalized data. So now we have train.norm that gives you normalized values of the trained data set. Valid.norm, that gives you the normalized values of the validate data set. Okay? So now we have everything set up. Now we need to train the model and populate this knn.accuracy data frame with the accuracy information that we want. Okay, and we're going to do this using a for loop. Okay, so we're going to use k equal to 1 through 20. So we have, well, I need to set up a chunk and then say for, okay, and then we say I in 1:20. Okay, so 1:20 will expand into a series starting from 1 to 20 in increments of 1. So you get 1, 2, 3, 4 up to 20. So I in 1 will iterate through that series. So I will be set equal to 1 and the code will get executed. So the code that needs to be executed should be given within the curly braces. So if you put one curly brace, R will automatically put the second curly brace and the code should come in between. Okay? So whatever code that we provide between the curly braces, that will be executed once with I equal to 1, next with I equal to 2, and so on for all the different values in this series. So it'll execute the code within the braces 20 times, okay, with I equal to 1 through 20. Okay. So what we need to do is run the KNN model and then use it to predict the validate set, compute the accuracy from that, right? So we say k.pred, and then we say KNN train equal to, now train.norm. So we have to use the normalized data. Okay? And then we use test, so that is valid.norm. Okay. And then we have to specify what the class is. So class here is the target. So train.norm cat medv. So that's our class. And then we have to specify how many neighbors we need to use, right? And that neighbor is going to be I. So first time around, k will be set equal to 1. Second time, k will be 2. Third time, k will be 3, and so on. Okay. So once you have the prediction here, then we can run confusion matrix, okay, with k.pred. So that will give you the predictions. Okay. So this code will generate an attribute object, and the object will have the predictions as the primary value, and then it will have probability and so on, also distances, but we don't want, we want only the prediction. And then we have to provide, okay, the actual values for the prediction, and that should go in as a factor. So valid.norm, so this is for the validate set. Okay, so we say that part will train the model, and then that model will be applied. So it does both the, in the previous examples, we used to set the model up and then do a prediction. We use the prediction method to predict. right? So this code does both at the same time. It trains the model with this data and with that as the target, and then applies the model with the validate data set and computes the predictions. Then we use that prediction and then the actual value. So that will give you the confusion matrix. Okay. And then the confusion matrix, okay, so we need to, the confusion matrix has, okay, there is, okay, so here is the confusion matrix. Oh, we didn't, well, let me just save it as X. Then we can look at what we have in there. Okay. All right, so if you see, if you look at X, you have overall. So within the list, we have overall. Overall has accuracy, kappa, and then accuracy lower and so on. So it has all the other accuracy measures there. So that's what we have to extract. We have to extract from the confusion matrix, okay, the overall object, and within the overall object, the first measure is accuracy. Okay, so that's what we have to do here. So that's our confusion matrix. If you want, we can save it in an object and then use that object, but we don't have to. So we can directly say overall, okay, and then the first one, in the overall, okay, that's our entire confusion matrix, dollar overall, and the first item in overall. Okay, so that is going to give us the accuracy, and we want to put that accuracy in this data frame, knn.accuracy. So knn.accuracy, okay, and the row in which we want to put that is I. Okay, first time I will be 1, you want to put the accuracy in the first row. Second time I will be 2, and you want to put it in the second row, and so on. So I, and then the column is the second column. Second column is where the accuracy has to be saved, because that's what is set up for accuracy. Okay. Now this is going to build the accuracy data frame with accuracy value for each possible k going from 1 through 20. Okay. So if you now look at knn accuracy from here, you will see that it's filled up with the accuracy value.